extensive tramway. So I'm going to quickly show you a selection of theoretical student projects. This is Paul Kelsall working on the banks of the River Trent, and it's a digitally enabled community where you don't all have to own a great big television, a bit like here in Concepcion when the World Cup is on, you share. And so his notion was really the sharing of all the other resources, but you had very spacious houses. He was quite critical of the Code for Sustainable Homes, as it doesn't address the economic, political, and fundamentally social problems that we face with growing concerns over climate change. It's entirely a technocratic agenda. Here we see three nice young architects really thinking conceptually about what a porch module might be. They're thinking about mundane things like muddy wellies and children's bicycles. A systems-built house for the meadows. And here we see a young student using CNC manufacturing as a way of bringing employment to the meadows in Nottingham. And he demonstrated this by making a 1:25 physical model. Something I was very pleased to see that in BOBO there was, in the architecture faculty, there was an equal use of model making. This is an interesting project for the site I first showed you by Jonathan Davies and Matthew Kidner, and we were delighted when they won the nationwide sustainable housing competition in 2010. It's almost a bit of Nottingham turned into, I'd like to say, a romantic Italian hill fort. So here we have very dense terraced housing, but making wonderful places for people to live. Very simply modeled, but deserved winners. On a neighboring site, David Brooks and Samantha Barclay designed terraced house is a very normal form of housing in Britain. And they understood the energetics of their house well enough to produce this Sankey diagram. They realized they weren't achieving zero carbon. And as part of this studio, we teach the students Ecotect, TAS, OptiVent. But interestingly, it's very often just in Excel that the packages are worked. They're not allowed to throw every single technology under the sun. There has to be a realism. I don't propose to go through all of these, but we've won, as a studio, both regional, national, and international recognition for this work. Here's Oliver Peach, Alexander Gosling, and Peter Phillips working in the meadows, which is actually one of the less privileged areas of Nottingham. Now, at Nottingham, we have a whole range of creative energy houses, and this is an article I wrote about one of them. We got permission to build a 1930s semi-detached house, but the other half of the house is actually a research laboratory. It's not in accordance with our current building regulations. I think it might be just about acceptable in Chile because it has single glazing. And we're in the process of taking this from the energetics of pre-war Britain, where coal was cheap and petrol was plentiful before the war, to being a code level 6 home, and it's being continuously lived in and monitored. The role of the students of ZCARS was, in a competition, devised the best way of taking it to code level 6. This enabled them as future architects. They're typically 1 year away from becoming qualified architects, of fully understanding the building physics and the codes and the restrictions. But as part of that, we actually got them to build at one-to-one their own cavity wall insulation with brick and block, so that they could then proceed to uprate them. And it's something that I believe in passionately. There is no better scale to understand architecture than at full size. This is a snippet from one of my books on concrete that explains how to achieve super insulation all the way down to 0.1 watts per meter squared degrees K. I actually much prefer my students to do U-value calculations. But when writing about insulation, it's very difficult to get people excited about insulation. Now, I understand in Chile you do not have tea cozies or tea hats. But in England, it's very important to keep your tea warm while it's brewing. And I think this is what we need to do with a lot of our houses. And I have to say, when I was writing about insulation, you know, I sought ways of making it more exciting. But the leader of our Green Party, Caroline Lucas, suggested if we could deploy much more insulation in our existing stock, some of which has lasted for 1,000 years, we would need no new nuclear power stations in Great Britain. So I'd now like to take you through the solar decathlon competition that we did in the year 2010. It was designed and built and assembled by students of the University of Nottingham. And this is us on site in Madrid, in what is going to become a new park. Again, this was a competition within my studio, and it was won by Rachel Lee, Chris Dalton, and Ben Hopkins. They won largely because they produced an L-shaped plan form that could either make terraced houses in Northern Europe or courtyard houses in Southern Europe. We had the very interesting challenge of the house being able to survive the hot, dry summer of Madrid and then return to Nottingham and be capable of coping with our cold winters, and as long as we don't get bad global warming, of relatively warm summers. We believe the Nottingham house is the first ever fully prefabricated low-carbon house that achieves Code Level 6 and Passive House standard. And these are the young people who made it. Ben, Rachel, and Chris in the front row were in 5th and 6th year in my design studio. And then young Vicky there is a 2nd year student, but she was known as our project manager. She was, in fact, our project manager. Chris, Rachel, and Ben tested their houses in the meadows, just like the other students in previous years in ZCARS. And here we see their arrangement of terraces with surrounded by existing terraces. The strange thing about the solar decathlon competition is you're given a pyramid of space and a plot, and you're not meant to be bigger than that. Most universities entering this competition, which started in North America, just make single-story pavilions. They're show homes, really, whereas our intention was to make a proper starter home for a couple with a young child or maybe older retired people. Chris and Rachel and Ben produced variations of the system to make much larger homes. And here is their final working drawings. It is made using timber cassettes. Originally, we wanted to use cross-laminated timber or massive timber, but our supplier couldn't provide that. Here is the ground floor plan. It's very compact. It has a draft lobby to keep the cold out, grey water recycling below the downstairs toilet, solar thermal storage. This is your route upstairs, a little kitchen, nominal heating from an air-to-air heat exchanger, and a very compact form. It has no bath, just a shower. Under Code for Sustainable Homes, you get points for leaving out the bath. I'm not sure I quite approve of that. But we knew we had a very compact plan form. Now, this house was not only designed by postgraduate students, it was built by undergraduate students and helped by wonderful technicians such as Dave Oliver. We were actually working in an old television studio that happens to be owned by my university. Now, here we have a very interesting inversion. Professor Brian Ford is fixing the cooked wood, that is treated softwood, to make durable. with the young architect Rachel Lee inspecting his work. So you have a reversal of normal experience. The U value of the walls of our house were 0.1 watts per meter squared degrees K, using recycled glass insulation that was supplied by our primary sponsor, Saint-Gobain, and had to be imported from Finland, including very clever plastic grips that didn't produce any thermal bridge. We then overclad the timber cassettes in a rigid insulation. But as many of you know, once you've got a very low U value, you have to restrict your air infiltration rate. And I've done this as a practicing architect, and the builders find it very strange that you really want to inspect every single junction, and you have to do it absolutely meticulously. And this was a greater challenge in this case because we were making 8 modules and trucking them. The largest one weighed 6,000 metric tons, which is pretty scary when it's being wheeled around by your young students. So these are the modules. It was chunked with open-sided modules, which is unusual in the European industry. But module 1 had all the complicated services in it. So it has the kitchen, the air-to-air heat exchanger, the grey water systems. All of those were proprietary products that we were able to get from industry. And then the house is completed. Probably module 5 and module 6 are the next most intensely serviced. We first demonstrated the house at an exhibition in London called EcoBuild. We fabricated this house in 8 weeks and we assembled it in 4 days. I've shown that timescale to main contractors in England, and they said, how on earth did you get your students to do it? The problem with competitions and exhibitions is you have deadlines and they don't move. It was very well received at EcoBuild, and we actually won a prize for the best use of timber. Now, this is a diagram of what contracting is like in Britain if you're using a traditional form of contract. The structural engineer, architect, and cost consultants feed into the main contract, and the product is a house, and you work with the disparate supply chain. The Nottingham house wasn't like that. There was no main contractor. The University of Nottingham Research and Design and Build team was about as diverse as the supply chain. So it was more like a partnering contract. So in theory, there was no adversarial behavior, but a lot of people in the process kept on asking who was the contractor or where is the contractor, only to be told that it was Vicky who was in second year. She was our project manager. The partnering process is a process that I've used to build bridges and public works of art or safety devices. This is Ballington Bridge in Suffolk and the Thames Water Tower, which is a feature on the Thames Ring Main. It's actually the world's largest public barometer and the first ever building in London to be powered by photovoltaic cells. But this is the heart of the Nottingham house. It's the dining area. As part of the competition, you had to entertain your neighbours. I think we cooked for France with a menu by the local Nottinghamshire Sat Bains. But this is also the heart of the house because this shows the way we cooled the house in the night time by allowing air to come down through what's a mini atrium. And we enhanced that cooling effect by using passive evaporated downdraft cooling, which was a separate research project by my colleague, Professor Brian Ford, and a Spanish company, Ingenatics. And in the prototyping architecture publication, there is a book chapter that explains that in much more detail. This is the night time. I think the previous one was the daytime. So we're allowing cold air through the house. In the previous mode, we're actually promoting the downdraft by spraying water, misting water into the top of our atrium. This is almost the technology of a very, very efficient diesel engine being used. You don't feel the water at the bottom of the atrium at all. I understand this technique might well work in Santiago because that is a hot, dry climate. This is not an appropriate technology for a humid climate. And that's one of the things that really interests me about low-energy architecture. It is rerouting architecture back into the culture of a place and the climate of a place. It's the opposite of the universal system of early modernism. And in a number of publications, you can read the results of the testing during the competition. And the house is now back on campus with the other creative energy homes. And what is very strange for me is I'm explaining it to you here in Chile today when the house is being officially opened as a permanent home back in Nottingham and will be lived in and tested typically by PhD students. They sort of are volunteers. So this is another view of the kitchen. The orange panel is acoustic absorbency, something the modern architect often forgets. Too many restaurants are so noisy that you can't hear each other. We should be able to make a performative architecture that is delightful to live in. That is what the contemporary architect should be doing. Very few of the products that we used in the house were made in Britain. The triple glazed windows were made in Germany. They're timber aluminium windows, Passive House accredited, which is a whole issue in itself. But they did achieve a U value of 0.5 watts per meter squared degrees K. We had some pretty big windows, as big windows as our calculations would allow. And I have to say, a triple glazed window is pretty heavy when you're a professor at the end, one end of it, with the glazing subcontractor at the other end. When we exhibited the house at EcoBuild, the then Minister of Housing, John Healy, recorded by Guillermo Guzman of Chile, said, "I think the Nottingham house is priceless. It is a demonstration of new ideas and how they can be put into practice. In the long term, we need to build this to this standard across the board." So this is a glimpse of the completed house. We used stainless steel mesh to minimize excess solar radiation on the southern side. There you get a very good idea of the cooked wood, which is the Plato process, taking a soft wood, making it as durable as hardwood. It's completed with aluminium sections. Aluminium, although having a high initial embodied energy, when recycled, only uses 5% of that energy and is available for humankind to use infinitely. 3/4 of all of the aluminium produced since 1888 is still in use or being recycled. On the roof, we had photovoltaic panels, again from Germany, and we were, in some senses, constrained by our very broad sponsorship that was headed up by Saint-Gobain. The other theme of our house was we grew all of the food that the students cooked during the competition. The house has now been widely published. There is a very interesting paper in ARQ by my colleague Graham Farmer on the importance of live projects for the learning of future architects. As I said, there's a book chapter in my own book, Prototyping Architecture. And, I understand that the faculty here is considering entering the Chilean version of this. It's hard work, but a brilliant way of learning about architecture and potentially informing the our common lives and the well-being of human ecology. Thank you very much.